Not long after going through the Rust book for the first time, I was watching a video where a Rust developer was using a pointer type called non-null, along with a method called asRef. The displayed code is illustrative of how he was using these. The non-null type is a wrapper for a raw pointer, and here a non-null instance is created from a reference to the variable I containing the value 42. Next, the asRef method on the non-null instance is called to get back a reference to the value of I. This is an advanced and unsafe thing to be doing, so don't worry at the minute about why you would want to do this. But the thing that caught my attention was that the developer described this use of asRef as dereferencing the pointer. This confused me. The method is called asRef, and it does indeed return a reference. So how is that dereferencing? On investigating this further, I came to understand something that had been annoying me about the deref trait. The deref trait, along with auto-dereferencing and deref coercion, are important features of the Rust language. In Rust method calls, a value of type T can appear to behave like a reference to a value of type T. For example, the len method implemented on string takes a reference to a string as its self-parameter, so we can call len like this. But here s is a string, which does not match the self-parameter of the len method signature. However, the compiler will automatically convert the string to a reference to a string for us, in order to match the signature. This is called auto-referencing. In this last example, s is a reference to a string, which again does not match the self-parameter of the len method signature. Here, the compiler will dereference the outer reference to leave a single reference that matches the signature. This is called auto-dereferencing. Auto-dereferencing may be applied by the compiler multiple times in the case of multiple nested references. These automatic conversions appear a lot in Rust, and so the distinction between a T and a reference to a T is often less obvious than between other types. We have a similar situation with a smart pointer to a value of type T and a reference to a value of type T. We can use identical syntax to access the value referenced by a boxed I32 and a reference to an I32. The reason this works is because of the deref trait. Whenever you use the dereference operator on a type that is not a reference, the compiler checks to see if that type implements the deref trait. If it does, the following substitution will be automatically made. Prior to applying the dereference operator, a call to the deref method is made, which returns a reference to the inner value of the box. The dereference operator is then applied to that reference to obtain the inner value. So similar to method call syntax for T and ref T, here we see dereferencing syntax blur the distinction between box T and ref T. I think these overlaps between T, ref T and T smart pointers were the cause of my confusion relating to the deref trait. When first learning about deref, I'd thought the choice of name was a bit strange. I wasn't expecting a method named deref to return a reference. But the reason a reference is returned rather than the actual value is to allow box and other implementers of deref to be used with non-copy types. Returning a non-copy type from the deref method would require the method to consume the box in order to move the value out of the box. There may be times when you want this behavior, but you don't want it to be the default. Once you have a reference, you can still choose to explicitly consume the value, so there's no loss of capability. For example, dereferencing a box string for use in an assignment will consume the string. I still thought the name choice was strange, a method called deref that returns a reference. But then I came across the asRef example and realized that for Rust developers, when dereferencing a pointer type that's not a reference, such as box or non-null, it's not important whether you get back a T or a ref T. Because a lot of the time you will use these interchangeably anyway, and where you do need one or the other specifically, the conversion is trivial. So in the strictest sense, dereferencing means following a pointer to obtain the value pointed to. But where, due to the restrictions of the Rust ownership model, a reference to the value is returned instead, this is also viewed as dereferencing. One last thing worth highlighting is the difference between automatic dereferencing and deref coercion. Auto-referencing and auto-dereferencing occur when a method does not exist on the type it's being used with. Using auto-ref and deref, the compiler will recursively check for a matching method signature and generate a compiler error if none is found. Here's an example that uses the method split ASCII whitespace on a box string value, but the method signature requires a string slice. When no method signature match is found for box string, the immutable and mutable reference to that type are checked. No match is found for these, so the box string is dereferenced to string and the same 3 checks are repeated on that type. This continues until a method signature match is finally found for a ref_stir string slice. This is similar to, but different from, deref coercion. Deref coercion occurs when assigning a value of type reft to a variable of type refu, or when passing a value of type reft as a parameter to a function that's expecting a type refu. Recursive dereferences of reft will be searched until a refu is returned, otherwise a compiler error is generated. In this example, we're passing a box string reference to a function that's expecting a string slice. Deref is called recursively, and in this case a matching type is eventually found. So, with deref coercion, the target type is known and searched for. With auto-dereferencing and autoreferencing, the method name is known and a matching signature is searched for. Thanks for watching, and please like and subscribe so that you don't miss out on the next video, which is on the subject of the turbofish.